Convolution defines how two signals interact mathematically, but what is the exact algebraic bridge that transforms it into cross-correlation? Take this standard convolution operation, where C sub I equals the sum of A sub j times B sub I minus j. Let's operate in slow motion. Visualize the two indices as physical, glowing pointers on two separate number lines. Notice what happens as the summation index, j, steps forward. The top pointer moves strictly to the right. But look at the target index, I minus j. Because j is subtracted, as j increases, this pointer is forced to move strictly to the left. One pointer reads forward, while the other reads backward, establishing the anti-parallel index phenomenon. If we map this anti-parallel movement onto a two-dimensional grid, every intersection represents a multiplication pair, where the indices add up to a constant k. Because I plus j equals a constant describes a line with a negative slope, the summation naturally forms diagonals sloping from top right to bottom left. This descending diagonal geometry is the classical mathematical signature of folding and filtering. But what happens if we intentionally pre-flip the sequence b sub I before convolving? Let's define a new, horizontally mirrored sequence, where every single element is reversed. Mathematically, this means substituting every b sub k with b sub n minus k. Plug this horizontally mirrored sequence back into the convolution formula. Watch the algebraic morphing. The term b sub I minus j elegantly transforms into b sub n minus the quantity I minus j. Distributing the negative sign, this simplifies perfectly into b sub n minus I plus j. Can we go deeper into it? What does the term n minus I plus j physically mean? Let's define a new variable for the spatial lag, d equals n minus I. The summation elegantly becomes the sum of a sub j times b sub j plus d. Look closely at the new pointers on our glowing number lines. As j increases to the right, j plus d also increases to the right. The exact moment we apply this double negative, the backward pointing triangle flips forward. The mathematical double negative has geometrically aligned the pointers. They are now moving perfectly parallel to each other. Returning to the two-dimensional grid, watch the geometry change. The summation diagonals seamlessly shift their slope from top right, bottom left to top left, bottom right. This exactly visualizes the cross-correlation formula. C sub d equals the sum of a sub I times b sub d plus I. And this mathematical double negative reveals that pattern matching isn't an entirely new operation. It is just convolution in disguise, achieved simply by feeding it a horizontally mirrored signal. It is the ultimate transition from folding and filtering to sliding and comparing.